Hey there, ready to have your mind blown. Imagine GPS so accurate it can pinpoint locations down to the centimeter.
Wow.
We're talking self-driving cars weaving through traffic with unbelievable precision.
Like dodging potholes.
Exactly. Drones landing packages on your balcony railing, even, wait for it, surgeons performing remote surgeries with robotic arms.
Now that's some next-level precision.
That's the kind of future we're diving into today, all thanks to this tiny chip that's making a huge leap in GPS technology.
I'm all ears.
Our source is a recent article from SciTech Daily, all about a breakthrough in optical atomic clocks, the super accurate timekeepers that could make all this and more a reality.
Optical atomic clocks, huh? That sounds pretty intense.
We're going to unpack how this chip works, why it's such a big deal, and what mind-blowing applications are on the horizon.
Sounds fascinating.
So buckle up and get ready for some serious aha moments. Okay, first things first, we need to talk about atomic clocks.
Right, the foundation.
Most of us just glance at our phones for the time without giving it much thought. But these atomic clocks are a whole different beast.
For sure.
How do they work and what makes them so special?
Well, at their core, atomic clocks are like a supercharged version of a regular clock.
Okay, I'm following.
Every clock needs an oscillator, something that creates a regular repeating signal, and a counter to keep track of those signals.
Like a pendulum swinging back and forth.
Exactly.
Yeah.
In a traditional clock, it's the pendulum, but with atomic clocks, the oscillator is an atom vibrating between two energy levels.
Atoms vibrating, so not a literal pendulum.
Not quite. But these vibrations happen at an incredibly specific and stable frequency, far more consistent than any mechanical oscillator. And that's what makes atomic clocks so amazingly accurate.
So it's like having a pendulum that never ever loses its rhythm.
Precisely. And just to give you some perspective, the atomic clocks used in today's GPS systems are already mind-bogglingly accurate, relying on microwaves to measure these atomic vibrations.
Microwaves, like in my kitchen.
Well, similar concept, but much more precise. But this new breakthrough uses light or optical frequencies to measure those vibrations, making them even more accurate.
So it's like using light instead of microwaves to measure those tiny vibrations.
Exactly. It's like going from a yardstick to a laser measuring tool.
Wow, that's quite the upgrade. But this new chip, that's where things get really interesting. They've managed to miniaturize this super precise optical atomic clock technology, right?
That's right. Optical atomic clocks used to be massive, complex systems that took up entire rooms and laboratories. But now, thanks to something called a microcomb, they've been shrunk down to a chip that could potentially fit on your fingertip.
A microcomb, I've never heard of that before.
It's a pretty recent innovation.
Okay, microcomb, I'm intrigued. Break it down for us. What exactly is this thing, and how does it work its magic?
Imagine a laser beam that, instead of being a single color, is split into a rainbow of very specific colors, equally spaced apart like the teeth of a comb. That's what our microcomb does. Each tooth in this comb of light represents a different frequency. And by locking one of these frequencies to the vibrations of the atoms, we can measure time with unbelievable accuracy.
So it's like using a rainbow to measure time.
You got it.
That's a pretty wild concept.
It is. And the really amazing part is that this microcomb bridges the gap between the super high frequencies of light used to measure the atomic vibrations and the lower radio frequencies that our electronics can understand and use. It's like having a translator between the atomic world and our everyday gadgets.
That's fascinating. But with such mind-boggling precision, how do they keep these microcomb clocks stable? It seems like the slightest hiccup could throw the whole thing off.
You've hit on a critical point. Maintaining stability is one of the biggest challenges with these systems.
So how do they do it?
The solution is pretty ingenious. Instead of one microcomb, they use two, each slightly offset from the other.
2 microcombs. Why 2?
Well, by cleverly combining the signals from these two microcombs, they create a stable, electronically measurable clock signal. It's like using two slightly out-of-sync metronomes to create a perfectly steady beat.
Okay, I'm starting to see the elegance in this approach. It's not just about measuring time accurately. It's about making sure those measurements stay consistent over time. That's crucial for something as precise as GPS, right?
Exactly. And it's this level of accuracy that opens up a whole world of possibilities beyond just better navigation.
And that's exactly where I want to go next, because it feels like this tiny chip could have a much bigger impact than just helping us find our way around town. What else could it unlock?
Imagine a world where autonomous vehicles can navigate flawlessly through rush hour traffic construction zones, even dense fog.
Yeah, that would be a game changer for sure.
Think about the implications for emergency response.
Oh yeah, that's huge.
Ambulances could arrive at the scene of an accident with pinpoint accuracy, potentially saving lives.
It's like a whole new level of efficiency and precision that we've never experienced before. But what about those scientific applications you mentioned earlier? It feels like this level of accuracy could unlock some incredible discoveries.
Absolutely. Think about monitoring the subtle shifts and changes in the Earth's surface.
Okay, I'm picturing like earthquakes and volcanoes and stuff.
With centimeter-level accuracy, scientists could track the movement of tectonic plates, predict volcanic eruptions with more certainty, and even monitor the effects of climate change with unprecedented detail.
Wow, so we're not just talking about better maps and self-driving cars. This technology could fundamentally change how we understand our planet.
Yes, and beyond Earth, imagine the impact on fields like astronomy and cosmology.
Okay, now we're really going deep.
Measuring time with this level of precision would allow us to detect gravitational waves from distant cosmic events with much greater sensitivity.
Gravitational waves, those are like ripples in space-time, right?
Exactly. We could study the expansion of the universe and test fundamental theories of physics in ways that were never before possible.
That's mind-blowing. It's like we're on the verge of unlocking a whole new era of scientific discovery, all thanks to this tiny chip.
And the exciting thing is, it's not just about the scientific breakthroughs. This technology has the potential to revolutionize everyday life in ways we can only begin to imagine. Take urban planning, for example.
Urban planning, how would centimeter-level GPS accuracy change how we design and build our cities?
Imagine creating smart cities that are incredibly efficient and responsive to the needs of their citizens. Traffic flow could be optimized in real-time. Public transportation could be seamlessly coordinated, and emergency services could respond to incidents with lightning speed.
So everything is just running like a well-oiled machine.
Exactly. We could even design buildings and infrastructure with much greater precision, maximizing space and resources.
That's a whole new way of thinking about urban living. It's incredible how this one advancement could have such a ripple effect across so many different areas of our lives. But let's not get too far ahead of ourselves. We've been talking about the potential, but what are some of the real-world challenges that need to be overcome before we see these applications become a reality?
One of the biggest hurdles is integration. Right now, the microcomb system requires several separate components, things like lasers, detectors, and electronics.
So it's kind of like a puzzle. We need to fit all the pieces together.
To make it truly practical for widespread use, we need to figure out how to integrate all of these elements onto a single chip.
So it's kind of like building a super complex circuit, but on a microscopic scale. What are the challenges in making something like that work?
It's a major engineering feat. It requires advances in materials, science, nanofabrication techniques, and a deep understanding of how light and matter interact at the nanoscale.
That sounds incredibly complex, but I imagine researchers are already working on these challenges, right?
Yeah. Absolutely.
Yeah.
There's a tremendous amount of research and development going into miniaturizing and integrating these systems. And while it's a complex task, the progress being made is truly impressive. Another important area of research is improving the robustness and reliability of these optical atomic clocks.
That makes sense. I mean, if we're going to rely on this technology for everything from self-driving cars to financial transactions, it needs to be incredibly stable and dependable.
Exactly. These systems need to be able to operate flawlessly in a variety of environments, from the extreme temperatures of space to the hustle and bustle of a busy city.
So it's got to be able to handle pretty much anything we throw at it.
They need to be resistant to vibrations, electromagnetic interference, and other factors that could affect their accuracy.
So it's not just about making them smaller and more integrated, it's about making them tough enough to handle real-world conditions.
Precisely. And finally, there's the question of cost. Right now, optical atomic clocks are still relatively expensive to produce.
Ah, yes, the economics of it all.
To make them accessible for widespread use, we need to find ways to manufacture them more efficiently.
That's a crucial point.
Yeah.
I mean, as amazing as this technology is, it won't have a truly transformative impact unless it's affordable and accessible to a wide range of industries and individuals.
You're absolutely right, and that's why there's a lot of focus on developing new manufacturing techniques and materials that can bring the cost down without compromising performance.
It sounds like there's still a lot of work to be done, but the progress being made is truly exciting, and it seems like we're not talking about something that's decades away.
No, not at all. This technology is advancing rapidly, and we could start seeing some of these real-world applications sooner than you might think.
Well, that's encouraging. It's amazing to think about how a seemingly simple concept, making clocks even more accurate, could unlock such a wide range of possibilities. But we've covered a lot of ground here before we move on. I want to hear from you what stands out to you most about this technology. What possibilities are you most excited about? Share your thoughts with us on social media, and we'll be right back to wrap up our deep dive into this incredible breakthrough.
Welcome back. It's amazing to think that something as fundamental as timekeeping could be on the verge of revolutionizing so many aspects of our world.
It really is. And, as we've been discussing all these potential applications, it strikes me that this tiny chip is really just a catalyst.
Oh, I like that. A
It's
catalyst.
a tool that unlocks possibilities, but the real transformation will come from how we choose to use it.
That's a great point. It's not just about the technology itself, but about our ingenuity and creativity in finding ways to apply it to solve real-world problems.
Right, exactly.
It reminds me of the invention of the microprocessor.
Oh, yeah, good analogy. In the beginning, no one could have predicted all the amazing things it would enable.
Exactly. It was a fundamental building block that sparked a digital revolution.
And that's what's so exciting about this optical atomic clock technology.
Yeah, totally.
It feels like it has that same potential to be a catalyst for a whole new wave of innovation.
I agree. It's hard to even fathom all the possibilities.
Like we've talked about self-driving cars, precision agriculture, even monitoring the Earth's movements, but I'm sure there are countless other possibilities that we haven't even considered yet.
Oh, absolutely. And that's what I find so inspiring about this field. It's a constant process of discovery and exploration.
It always feels like there's something new just around the corner.
As this technology matures and becomes more widely available, we can expect to see a surge of new ideas and applications emerge.
So what you're saying is that we're just scratching the surface of what's possible with this technology.
Absolutely. We're at the beginning of a technological journey, and the most exciting discoveries are likely still ahead of us.
That's a tantalizing thought. It's like we're standing on the edge of a new frontier with a whole universe of possibilities waiting to be explored.
And the best part is that everyone listening can be a part of this journey.
Oh, that's a great point.
Think about the problems you see in the world, the things you're passionate about. Could this technology, this ability to measure time and location with incredible precision, be a part of the solution?
That's a great question for our listeners to ponder. If centimeter-level accuracy becomes commonplace, what are the challenges you would want to tackle? What world-changing applications would you envision?
We'd love to hear your thoughts and ideas. Share them with us on social media, and let's keep the conversation going.
That's a wrap for this deep dive, but the exploration doesn't end here.
Definitely not. This is just the beginning.
We've only scratched the surface of this incredible technology and its potential to reshape our world, so keep those imaginations firing. Stay curious, and we'll catch you on our next deep dive into the fascinating world of science and technology.